This is the final video before the pour. We have cement. Our pump truck's coming in about 20 minutes, and then we have at 10 o'clock, another 30 minutes after that, our first truck. We're estimating about 7 trucks today of cement. As we're preparing, I got a bunch of friends and guys from work that are helping out this morning. We got Red over there. We got Eddie right here. We got Jason. I got Steven over there. My dad is going to be operating the old vibrator. So basically, we're all ready today. All right. So I'm going to give a quick walkthrough, and in this video, I'm going to explain everything that I've learned or done through this whole project. So there'll be a good primer on pouring with fast foot, putting a drainage plane in, doing a passive radon system, interior piers, whatever it is that I figured out like along the way, some of the products I use. All right, so let's get to it. So the very first thing that you'll notice here is that we have the perimeter footing. This is going to be an ICF foundation. So I'm doing a 6-inch pour ICF foundation and wall. And on that, I have a 14-inch tall footer, and it's going to be at a 4,000 psi. We're originally going to do a 5 slump, which is pretty thick. That's standard for a footer. But because we have a pump truck, and it's a big pump truck, it's actually almost a 40-meter boom truck to get every piece of this foundation in one pour. They said that it loses an inch, so they said pump it up. He actually suggested 7 inches of slump, but I'm going to go with 6 inch, and we could always water it down a little bit if we need to work it. But anyway, we had tons of number 4 rebar in here. I did 3 courses of number 4 rebar, and I also did some widened footings at some spots where the engineer called out. You can kind of see here. We also did, we made a rebar jig. We showed in another video to make these verticals, alternating them each way, and they come out of the ground, out of the top of that footer, probably about like 20-something inches or so. And you know, we also use these tools, this system right here. I forget what it's called. But it's this vertical system that holds, and these spreaders. I actually really like this system. I don't think it was the right setup for this footer though. I would have done this differently had I did it. If I had because I'm so tall on this footer, these really should have sat lower in the bottom third of the cement, because what ends up happening with footers and all cement basically, the load on top puts compression at the top of your footer and tensile at the bottom. So you really want your rebar not to be in the middle. You want it to be at the bottom for it to be the absolute strongest. Otherwise, if it did fail, you could technically get a shear fracture and it would create a hinge. But the bottom line is we're not even coming close to those because we're over-engineered. So it's all good. But all things held equal, this would have been a great product if my footer was, let's say that, maybe a 12-inch footer or a 10-inch footer. But anyway, that's something I learned there. It does hold these verticals up really nice with this other coarser rebar, and on this particular product, this is the ICF. The webbing is high enough to basically go over these without any problems. So when that's there, I already have my first coarser rebar right at the bottom, which is actually really good for strength on the wall. Then, as we go up, we're going to go 24 on center, which is what we have here, vertical and horizontal, so basically roughly every other course. And below this footer, another detail you'll see here is there's about 4 to 6 inches of drainage rock. That's 57 stone, clean stone. And what that ends up doing is it creates a very, the entire footer is a drainage plane under it. And it's actually made for like a really clean job site. It's about, to do this everywhere in this footer was probably about $3,000 worth of stone, but it was definitely worth it. I mean, as a solo build, it's taken me many months, as my cameraman, my wife, can attest.
Camera woman.
And but it was worth it because I don't have to work in the mud. And we actually had a monsoon, probably what would you say, about a week or so. And let me show you where this all drains out to. Let's go this way. Don't worry, the cameraman never dies. It'll be fine. So after this is poured, this is actually French Grain Man. They have this like knife cut corrugated pipe, which is actually really heavy duty. That's going to go on the perimeter drain. So all of that stone. If anything got inside, it would actually drain into this perimeter drain. Anything from the outside should get to the here, and this should really stay dry for the remainder of the project. But until then, this is where it was going. This right here is a step-down foundation. The footing that we put in last minute under the porch, I was like, we could put some sort of, yeah, you're not going to pick up my audio, you're so far away.
Sorry.
I decided to put like a last minute storage thing. We could put like ATV or a riding lawnmower on this thing under it. Well, basically what this ended up doing, it created an opportunity and a challenge at the same time. Basically everything drained from that part down to here really well, right? Because it's just going to flow. So that was, everything stayed very dry up there, obviously, and it flowed all under that drainage plane down into here. This right here, I got this off of Facebook Marketplace. It's actually Old County sewer line or something like that, but it's a 9-inch line that I got in 40-foot sticks. We had to cut with a chainsaw, and we ran it all the way back. I took the forestry mulcher and cleared the stretch into the woods, and then the excavator and dug a trench till I got to daylight, which took about 150 feet. So I got this pipe running down there at a pitch. So basically everything flows into here and then flew right out of here. So honestly, it worked great. I dug it down a little extra so any sediment wouldn't go in the pipe. It would kind of settle here, and then I just scooped it out the next day. That worked perfect. Long term, I have a drain inside the basement, just as like a service drain if I ever needed to clean something. We'll go under, and then this over here, yeah, you might want to come over here and take a look.
Yeah, give me 1 second to come around.
Yeah. So if you look over here, I got a 6-inch and a 4-inch right here. So this 4-inch is going to go to the perforated drain that I showed you over there, that French drain man with a knife cut. It's going to be wrapped like a burrito in fabric and this 57 stone all around the perimeter. There'll also be waterproofing that goes on this, and then a dimple mat that creates a capillary break. So that's going to have like boots and a belt and suspender approach for damp proofing and waterproofing. Plus this fast foot that's here, this is a capillary break all of itself. That's why we actually built these up. These footers will never get wet. Plus they'll cure very strong because they're in a very controlled environment in a bag like that. So it actually makes them even stronger. And basically I got a 6-inch main line here that's going to accept all of the closed pipe for gutter systems. So all the gutters coming into here, all the perforated drain coming into here. Then I'm going to have a clean out that goes up here because I have this big drop. Then it's all going to go down. Over here, I'm going to be forming up my own cement channel drain, like a U drain. These are the grates for it. They're going to go across here, and that will actually also act as like an open pipe. The inspiration was the Roman aqueducts for this, FYI. Then over here, we get to, this is going to be the bottom of that catch basin, the bottom of that U drain. It's going to go down and then dump into this hole. Same thing happens on this side, down into this hole. And then over here, if you look closer, I'm going to build a cement form for this. And then that drain that you're actually standing on is going to go, that grate is going to go on top of here. And essentially, I'm going to have this flush with the service port here that's got some slits, like a drain cover. And everything should pretty much dump out into here and go out into the woods. If any sediment hit, I can clean this out once or twice a year, you know, if anything got in there. This drain line is going to go all the way out till roughly about those 2 trees. And then after that, we're actually going to dig down and put a water catch. So I'm going to get like a buried water tank that's probably going to hold, you know, maybe 10 to 15,000 gallons, which will eventually be the service line for the irrigation system. We got our well up there, and we're also doing a geothermal HVAC system, and it's going to be a closed loop but with a bleed. So technically an open loop, and to boost the efficiency of the system, it wants to shoot out like hot water or cold water, depending on how you're running it. And if you give a place for it to go, it increases the efficiency. Like it goes from like a 50 SEER system to like a 75 SEER system. So it's already super efficient to insanely efficient. But what we'll do is actually dump that into that tank too. So we'll also be capturing that basically gray water that we'll be using for irrigation. In here, we're going to be doing a slab. That's going to be in a later stage. Today we're just doing the perimeter footings and the spot footings. Check out this interior pier system that we did. I think it's pretty cool. I'll help you out. All right. So if you look over here, we formed up. These ones I just put it on top of Stego wrap. I thought it would be too much work to make individual bags like we did for the footer. It's very fast for the straight runs, but not for corners. So I just put Stego wrap, did the tape. This is actually the commercial grade. If you have a project that's big enough, it's a little bit cheaper, and actually it's pretty high. I think it's like an 18 mil or something like that. Code I think is like 6 mil. So it's pretty good, and it's really held up. I tried not to walk on it, but you know, it's really held up to it, not punctured. So inside here we have our rebar layout. Where there was ones that were close together, I combined them. This I got from like Akbar Leather, like Instagram account or something. It's pretty genius what they did. They made these little you know, braces to hold the rebar. I did one improvement on it. I put these little notches on it, which I found like held it really tight and in place, and I've done a video on that too. But basically we're going to do these pads. These are only 12 inches versus the 14 inches on the outside. And after this gets poured, the next step will be to do basically like a sonotube column at the right height and grade. And I got a guy in town that's going to be basically manufacturing or fabricating some rings for me. That we're going to make some ring cages for it. And then that'll be the next phase. And this is probably the last detail that I'd show. This is a passive radon system. So you can kind of see where this pipe goes. Excuse me. It's a slightly different color because it's not wet. This goes the whole run of the house, this way and that way. And basically it's a perforated pipe, and it sits right in the middle of this aggregate. So all that drainage plane not only captures water, but when this house has got a roof over it, it's not going to have water in here. What's going to capture is gas. So if there's any radon system, any radon basically under this system will essentially catch it. It'll percolate through here, and this is actually where the fireplace is going to be. That's why we framed this whole thing out, so we have the option to put stone or something if we wanted to. But at minimum, this is going to go through the chase all the way up to the chimney and create a straight run, which allows you to do a passive system. And basically, if you ever blew on the top of a bottle like that, it creates low pressure here, or basically it's like the Venturi effect, I think it is. Bernoulli principle, not the Venturi effect. And it basically creates suction out of here. So that suction basically creates negative pressure that actually sucks up. If this gas is going to build up and go somewhere, it's going to go here. And you don't have to have a fan for it. So I think that's pretty much the whole nuts and bolts of it. Hopefully you learned something. And at minimum, we have a good video if we're trying to figure out where stuff is under the slab. I can watch it. So thank you. Bye.